Good day everyone! Today we're going to talk about the derivatives of a function, the theorems on differentiation, as well as the derivatives of trigonometric functions. For you to further understand, we're going to give you some examples and we're going to solve them firsthand. What I am going to show you today is how to get the derivative of a function. So we have here the givens x squared minus 9, which is our function, and the coordinates 4 and 7. So this is the formula of how to get the slope of a tangent line. Let us recall the difference quotient equation, which is the limitation of f of x plus change of x minus f of x all over change of x, where change of x approaches to 0. In here, we will let h equal to change of x. At this juncture, we will just apply the formula. So we have here the limitation of x plus h squared. We have this squared here because in the formula, we also have squared. So we just add the h on x. And then, minus 9 will remain because it's in the formula. So minus 9. After it, we will subtract this to the function. So our function is x squared minus 9 all over h, where h approaches to 0. So we are going to expand this one into this one. So we are just going to multiply the two, which is x plus h times x plus h. Using the FOIL method, we will come up with this one. So after we simplify everything, we will get this resultant answer. So x squared plus 2hx plus h squared. Since we are done simplifying this, we are going to proceed simplifying this one. So, just copy the negative 9, and then you have to multiply this negative sign to this function. So, negative times x squared, it would be equal to negative x squared. Negative times negative 9, it would be equal to positive 9. So, all over h, where h approaches to 0. This time, we can now cancel this and this. So the remaining in the equation would be this. So limitation of 2hx times plus h squared all over h, where h approaches to 0. This time we can now cancel the like terms, which are the x squared and negative x squared, negative 9 and positive 9. So the remaining in the equation would be the limitation of 2hx plus h squared all over h, where h approaches to 0. Since we have the same variable here, we can factor it out. It would be h times 2x plus h. If you simplify it, it would be the same with this one. All over h, where h approaches to 0. So we can now cancel the h here. So the remaining on our equation would be this. It is the limitation of 2x, where h approaches to 0, plus the limitation of h, where h approaches to 0. Since h approaches to 0, the value of this one would be equal to 0. Hence, the final answer would be the slope of tangent line, which is equal to 2x. We are not yet done because this is only the equation for getting our slope. So we need to substitute the value of this one into this. So the resulting would be this, and then 2 times 4, it would be equal to m is equal to 8. This is the slope of our tangent line.
So we're going to find the equation of tangent line, which is the point of 4 and 7. Since the x sub 1 will be the 4 and y sub 1 will be the 7. So we're going to use this method, which is y minus y sub 1 is equal to m multiplied by x minus x sub 1. We're going to substitute the y sub 1, which is y sub 1 will be the 7, and m where 8, and multiply by x minus x sub 1, where the x sub 1 is equal to 4.
and your hair stands up to the sun, stay summer strong with Pantene's new UV Rest
Then,
Limited Edition.
we only need to copy this. Y minus 7 is equal to, before that, we're going to multiply the m and x sub 1, which is 8 multiplied by 4 is equal to 32. So we're going to copy this. The 8x is equal to 32. So we're going to copy this. The y minus 7 is equal to, we're going to distribute this x multiplied by x minus 4. So x multiplied by x is equal to 8x. 8 multiplied by negative 4 is equal to negative 32. So we're going to find the equation of y, where the y is the value of the equation of tangent line. We're going to apply the APE, or addition property equality, by adding the 7 in both sides, where the answer will be y is equal to 8x minus 32 plus 7. So by simplifying this, we're going to get this answer of y minus 8x minus 25. This is the equation of our tangent line.
Good day, everyone. We are talking about sum and difference rule. But before that, according to this rule, the derivative of sum and difference is equal to sum and difference of derivatives of two functions. This function is an example of sum and difference derivative rule. F of x, x to the power of 6 minus 7, x to the power of 5 plus 13. Stop. But before we proceed, let me remind you, the constant rule, according to the constant rule, all constant is equal to 0, and also the power rule. All the power should be bring down and times to the constant, and then all the remaining power minus 1. So 6x to the power of 6 minus 1 minus 5 times 7 x 5 minus 1 plus 0. This is the final answer. 6x to the power of 5 minus 35x to the power of 4. That's all. Thank you. To simplify it, the final answer is 6 to the x to the power of 5 minus 35x to the power of 4. That's all. Thank you.
Now, in this given function, we are going to use the sum rule. So, first is the f of x. F of x is equal to x raised to the power of negative 4, and the g of x is equal to 11x cubed. So, the equation for the sum rule is f prime plus g prime. To get that, the results would be, in the given function, the results would be this. Negative 4x raised to the power of negative 5 plus 33x squared. Now, how did this happen? First, bring down negative 4, so you got negative 4. X raised to the power of negative 5 minus 1, so negative 5 minus 1 is, negative 4 minus 1 is 5. So that's how you got negative 4 x raised to the power of negative 5 plus 33x squared. So just like in this part, bring down 3, so 3 times 11 is 33, so that's how you get 33. X, 3 minus 1 is 2. So this would be the next. So how did this happen? Because the exponent is negative, we need it to become a positive. We made it into a fraction form. If you simplify this, it will also result to this. So negative 4 all over x raised to the power of 5 plus 33x squared.
Good day, everyone. Today we're going to help you understand the quotient rule. So the quotient rule is f prime of x times g of x minus g prime of x times f of x all over g squared. So remember, we need to take derivatives one at a time and not simultaneously. So our given is f of x equals 2x to the power of 6 plus 3, and our g of x is 5x squared. So next is we're going to identify the f of x and the g of x and the derivatives of them. So our f of x is 2x to the power of 6 plus 3, and our g of x is 5x squared, and the derivation of our f of x is 12x to the power of 5 5 and the derivation of the g of x is 10x. So how did this happen? So first is you need to bring down the exponent and multiply it. So 2 times 6 is 12 and you need to subtract the n. So our n is 6, so you need to subtract it. So 6 minus 1 is 5, so is equals to 12x to the power of 5, so plus 3. So according to constant rule, the derivation of a constant is 0. So next is the g of x. So same is you need to bring down the exponent and multiply it. So 5 times 2 is 10. Then our n is 2, so 2 minus 1 is equals to 1, so you don't need to write it. So next is we're going to use the formula by substituting it. So to substitute, f prime of x is 12x to the power of 5 and our g of x is 5x squared and our g prime of x is 10x and our f of x is 2x to the power of 6 plus 3 all over g squared and our g squared is 5x squared to the power of 2.
The next step is this. So to get this, 12x times 5x is 60. So I just add the both exponents. 5 and 2 is 7. Next is this part. So 10 times 2 is 20. 6 plus 1 is 7. 10 times 3 is 30 and copy x. For the denominator, copy the denominator. Next is this. So to get this, because they both have the same exponent, so you can subtract them. So 60 minus 20 is 40. So 40x raised to the power of 7. Copy 30x. So 40x minus 7 minus 30 all over 25x raised to the power of 4. To get this, 5 squared is 25 and add the exponent. So that's how you got 25x raised to the power of 4. Because they have like terms, it's just 5, we separated 5. So 5, if you simplify this one, it is equal to this equation. So we did this in order to factor out 5x from this equation. In order for 5x to be cancelled out from both numerator and denominator, which will end up with just this. So the final answer is 8x raised to the power of 6 minus 6 all over 5x cubed. With the use of the quotient rule, we now have obtained the first order of derivative, which is 8x raised to the power of 6 minus 6 all over 5x cubed.
Now, we're going to give you an example about the derivative of a trigonometric function. So my example here is y is equal to cosecant x minus the quantity of 3x cubed times the sine x. So before we get to examine the next level or the next steps about how to solve this, we have to remember the different theorems about the derivatives of each trigonometric. For example, sine x is equal to the derivative of sine x is equal to cosine x. The derivative of cosine x is equal to sine x, and the derivative of tan x is equal to secant squared x. Then the derivative of tangent x is equal to cosecant squared x. Cosecant x is equal to the secant x tan x. Then the derivative of cosecant x is equal to negative cosecant x cotangent x. So after knowing this, we will now find the derivative of this first function, which is the cosecant x. Cosecant x here is the derivative of cosecant x is equal to negative cosecant x and cotangent x. But before that, before we will put this one, we have to consider this function here. As you can see, this is these two are two different functions: the 3x cubed and the sine x. So in here, we're going to apply the product rule, which is the f prime times g plus g prime times f. We're going to apply the product rule in finding the derivatives, which is f prime times g plus g prime times f. So in here, we have to identify what is the f of x and g of x. So our f of x here is the 3x to the power of 3, and our g here is the sine x. So the derivative of 3x cubed is equal to 9x squared, and the derivative of our sine x is equal to the cosine x, which is here. And after finding this, after finding the derivatives of f of x and g of x, we'll now follow this one. So our f prime or f of f prime x is equal to 9x squared. You have to substitute it here. Then our g is equal to sine x, which is this one, and our g prime or our g prime of x is equal to cosine x. Then our f prime, our f rather, is equal to 3x cubed. So after finding it all, you can now, after substituting it all, we can now find or look at this equation, or if it is stuck. So the next thing that we are going to do here is we need to multiply this one and this one. So the resulting answer would be here, this one. So negative cosecant x cotangent x minus 9x squared sine x plus 3x cubed cosecant x. Why? We just, as what I've said earlier, we just have to multiply these two here and add them both. So the next step would be finding the final answer. So in here, you just have to add these two, or these two, and simplifying it. So the answer would be this one. So the y prime is now equal to negative cosecant x cotangent x minus 9x squared sine x minus 3x cubed cosecant x. Why negative here? It is because we distributed this negative sign to this function and this function. So we now obtain two negative here. Understood? So again, our final answer here is equal to y prime is equal to cosecant x cotangent x minus 9x squared. I'm sorry for that. Sine x minus 3x cubed cosecant x. That will be all. Thank you.